Hello everyone, we're looking at question 2 of winter 2008 paper 4 9702. A part reads define specific latent heat of fusion. So obviously fusion is about melting and it involves a change in state. So what we will write is it is the amount of heat energy required. It is the amount of heat energy required to change the state of an object of mass 1 kg. Writing this mass means you're talking about specific. If you omit this mass 1 kg, that means you're talking about just latent heat of fusion of mass 1 kg from solid to liquid or vice versa without a change in temperature. This is extremely important and I hope everyone knows how whenever there is a change in state there is no change in temperature. That is usually showed to us by the cooling heating curves. Moving on towards B part, that says some crushed ice at 0 degrees Celsius is placed in a funnel together with an electric heater as shown in figure 2.1. The mass of water collected in the beaker in a measured interval of time is determined with the heater switched off. The mass is then found with the beaker switched on. The energy supplied to the heater is also measured. For both measurements, water is not collected until melting occurs at a constant rate. So we know that when we say it's melting at a constant rate, that means that when the water is dripping, it is dripping at a constant rate. So there's you can say a constant dripping. So we can simply write there's constant dripping. The droplets that are being dropped, they are very constant and at a fixed rate. We have the heater switched off, we have the mass of water measured, energy supplied was 0 and we measured it for 10 minutes, we measured this for 5 minutes, we have 18,000 joules then supplied with, and then you have measured the mass 64.7. State why the mass of water is determined with the heater switched off. Okay. So essentially the purpose of this experiment is to see how much water was collected when the heater was on. So let's just say that when I turn the heater on, I have an ice cube and I put a heater in front of it, and the final mass of water in that glass, it becomes, let's say, 20 grams. But now I want to know how effective the heater was or how much the heater aided in melting of this ice. So I would want to know the initial mass of the ice, initial mass of this glass, and then I can subtract it from the initial, then I can subtract this 20 gram from my initial mass to see how much mass was given to us when the heater was on. So if I want to see how much water is collected when we turn the heater on, but in order to know that, I want to know the initial mass of the water. So when we say heater is switched off, I can say I want to measure how much ice melts just from the heat in the air, because obviously even if you do not turn the heater on, the ice will still melt because of the atmosphere, because of the heat in the air. So I want to measure my initial mass, that is only because of the atmosphere, and then when I turn the heater on, and then I can subtract these values so I can get a know-how of what my heater is melting. So in simple words, I will say to measure how much ice melts, it is to see how much ice melts from the atmosphere. Or I can say heat in the air, in simple words. And I hope whatever I said makes sense. Moving on towards the second part, suggest how it can be determined that the ice is melting at a constant rate, something I just discussed earlier as well. When we want to know if it is melting at a constant rate, we can determine that by constant dripping rate. Constant dripping rate. And then we have calculate a value for the specific latent heat of fusion of ice. First foremost step is you write in the formula. Specific latent heat of fusion is E equals mL. This is the energy, the mass, the latent heat of fusion that we have to find. So the real issue is not the energy. If we go back to the table, we can see how much energy was supplied. It was 18,000. I need to see what units they're asking. They're asking for kilojoules, so I have to write 18 instead of 18,000 to convert joules into kilojoules. So now my problem is mass. I want to know what was the mass of water collected when the heater was on. How do I do that? That can only be done if I subtract these two, right? I have the final, I have when the heater was switched on. When the heater is switched on, I subtract these so I can see how much heater gave me. However, there is an issue. We measured this for 10 minutes and we measured this for 5 minutes. If you want to measure something, you have to make sure you keep other things constant. And in this case, it's not constant here. I have to find this for 5 minutes. That is more feasible than finding this for 10 minutes because we do not know how effectively the heater is working or how much the intensity is, or if the intensity of the heater is even kept constant or not. So it's better you find this 10 minutes into 5 minutes. So if I want to find it for 5 minutes, I have to divide this by 2, which is going to give me 8.3. So I can say 8.3 grams of water was collected with just the atmospheric air, but then when I turned the heater on, this was collected 64.7. And this 64.7, I want to make it clear that this 64.7 gram is not just from heater. You can see that even when the heater was switched off, we still got some mass of water because still, due to the atmospheric air, the ice continued melting. And then when the heater switched on, it was due to the atmospheric air plus the heater. So if I want to just calculate the heater, I will subtract 64.7 from 8.3 so I can just know how much my heater worked. So when I do this, the mass I get is 56.4 grams. And that is, you have all the values. 56.4 grams, but I want it in kilograms, so 56.4 into 10 raised to the power minus 3 into L. You just divide 18 by 56.4 into 10 raised to the power minus 3, and you should be getting 320 kilojoules per kilogram. And this is it for question number 2.